Hello all. Let's move into the problem number 32 now. So let's read out the problem. This problem is talking about Pandigital product. So what is Pandigital? Pandigital is saying 1 through 9 Pandigital is a number where you have 1 through 9 all the digits available exactly once. That means your number has to be 9-digit number and it should contain all the digits. Order doesn't matter, all you need, but you need to have every numbers at least once. Okay, one ones, two ones, like that. Here it says it has special property where if you multiply 39 and to the 186, then it becomes 7254. Now if you take these three pair, 39, 86 and 7284, combine these three numbers, then whatever you get, that is a 1 to 9 Pandigital. That means if you combine all these three numbers, you see you have 1 here, you have 2 here, you have 3 here, 4 here, just like that you have all 1 to 9 Pandigital number. Now the question is asking, find out all possible such products which are Pandigital. Okay, so we'll have to find out all the possible products. Here the 39 and 186 is one examples. Okay, and we'll have to sum them up. Okay, and here he says some product can be obtained more than one way. We'll have to include only one. That means we'll have to do the distinct. Okay, if you find it repetitive twice, you'll have to do the distinct. Okay, so here one thing, let's try to find out. If you see here, in this case 39 is a 2-digit number and 186 is 3-digit number and the product is 4-digit number. So 2 plus 3 is 5 and plus product 4, so total become 9. Now if we try to multiply one 2-digit with one 4-digit, I think that's not going, that will cross more than 10-digit. Let's try to find out. So we'll have to find out, let's say this is the smaller side product and this is the larger side product. What are the different digit range? Because we will not be searching 1 million multiplied by 1 million, because that's not possible. That will create total number of digits way more than 9 digits. So we will not be doing that. So we'll have to find out what will be our range. Okay. So for example, if I take 2-digit, say minimum 2-digit number and multiply it by minimum 4-digit number. Okay. So if you see this is 2 plus 4, this is 6, and you see 1, 2, 3, 4, 5, and this is again 5. 6 plus 5 is 11. So that's not possible. But if you multiply this, then it is 2 plus 3, 5, plus 4, 9. That's possible. That means one number can be 2-digit, another number can be 3-digit. That's possible. And similarly, if you take the 1-digit number, let's say I take some 1-digit number 4, and if I multiply it by 4-digit number, then this is 4 plus 1, 5, and this is again 4. So that means 9. So this is also possible. So that means on my product side, let's say I want to multiply A by B. So I'll say A can vary from 1-digit to 2-digit. So A will be in range 99. Okay, and B can vary from 3-digit to 4-digit. Yeah, again, for example, you can take say 99, largest product, and you multiply it by say 2-digit, another 99. Okay, so that becomes 4 plus 4, 8. It is not coming as 9-digit. So therefore B must be within a range of 3-digit. So I'll take it from 101 till the 4-digit. Okay, so 9999. So this should be our range. Okay, and A should be 2 to this. Okay, because there's no point of multiplying with 1. It's the same thing. Okay, so that should be our range, and if we try to multiply this range and check the combination, that should give us our answer. But before we proceed, I think we'll have to figure out a function. We'll have to create a function that will give us whether this pair is Pandigital or not. So let's try to do something like this. Let's say I want to create a set with all the number 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see what it gives. You see, it gives us the set of all numbers. Okay, it's in character set of all the numbers. that should be enough for us, or yeah, that should be fine. Okay, we can deal with this. So I'll just create a function def is span digit. Okay, span digit. Then here I'll take 3 numbers, that will be A, B and C. You know, A is the multiplier, B is multiplicand, and C is the product. Okay, so I'll just take these 3 numbers and I'll just try to check whether their product will be Pandigital or not. So how can I check it? Okay, not product is already there. In fact, I could take just A and B instead, but that's fine. I'll just leave it like that. So here I'll just create all digits in this. I want to concatenate. Of course, we can create another separate function, numerical function for concatenate, but for simplicity, I'll just use the string version here. String B, string C. Okay, so I got this concatenated number. Now here I want to check if length all digit. If length of all digit not equal to 9, then we know this is not a Pandigital. So I'll just return false. Otherwise, I'll just combine this as set of all digits and compare that with all digit sets which we have just created. Okay, so this one should be all digit set. Okay, let's say we have created this set. Then I want to compare that with this, and I can just return this value. Okay, so that function should give us a Pandigit number. Now let's test this. Is Pandigit. So we had the number in the in our problem, the 39, 186 and 7254. So I'll just check 39, 186 and 7254. This is true. Okay, and if we just change any value, this is false. So I think our function is working. Now what we'll do is we'll create this loop as mentioned here. Okay, so let's say I create all products as a list, and this will just keep we'll just save all of our products here, because that's what we are interested in. And here we'll just have to create a loop for I in range 99. Okay, and then I'll just do for j in range 99 till 9999, let's say. And here what we'll do is, yeah, for the simplest version of the problem will be like this: if is Pandigit, then I'll try I, j and I multiplied by j. Okay, then what I'll do, I'll write all products dot append. I'll just keep track of I multiplied by j. So that should work, but we can do it better. So think about it. For 2-digit number, if 2-digit number is say 10, 20 and those kind of things, then we for example 10, 20, in this case we have 0, but remember 0 is not part of our solution, so we should not try with this 0 because that's not required. Okay, and similarly if you see something like 11, 22, so like multiplier of 11 for 2-digit number, here 1 is twice, 2 is twice, like that. 1, 2, these numbers are repeating, so in that case that cannot be our answer, so we'll just exclude that. How can we do that? Just write if I modular division 11, that means divided by 11 is equal to 0, or I modular division 10 equal to 0, then I'll just do continue. That means we'll not go further, we'll just skip it. Now similarly for j cases, if it's coming any 0, let's say 100, 200, 300, so these numbers if we multiply, they cannot be Pandigital because 0 can't be the part of the solution. So therefore we'll just do this. If j modular division of 10 equal to 0, then continue. And another thing that we can do is, let's say 999 multiplied by 9999. Okay, 4 numbers. That number is again crossing more than that. Okay, I'll leave that. Okay, probably we could still, squeeze this range. So yeah, so I think that should be our range. Let's try this out. Okay, and let's see what happens. Okay, got the answer. Now let's check out our all products. Okay, these are the products. If you say I want to see the original ij value as well, so what we can do, we can just print it, print I and j, or I can save it in another list. But yeah, these are the numbers. So you see 4 into 1738, just like that. So we got this combination, and our original combination was 39 186. This is also part of it. So most likely our answer is correct. If we just sum them up, okay, if we just sum them, we get 56,370. 56370. Let's check it out. 56370. Okay, our answer is not correct this time. Let's see what is the issue. Okay, we might have some duplicates. Let's check it out. 67295346. Yeah, 5346 is duplicated. Okay, so we'll have to remove the duplicate. So let me check this as set, and then let's do sum. This is 45,228. I think this should be our answer. Let's check this. 532. Yeah, here is our answer. Okay, thanks for watching. That's it for the current problem. Coming up next is problem number 33.